Okay, let's unpack this. Have you ever noticed how seamlessly all the different apps and services on your phone or computer talk to each other?
Yeah, it's something we almost take for granted now, isn't it?
Totally. You log
Yep.
into a website using your Google account maybe, or your weather app instantly pulls up the forecast for like your exact location.
Or booking flights.
Exactly. Picking a flight, and the app effortlessly gathers details from a dozen different airlines. It often feels a bit like magic, right?
It really does. But what's fascinating here is that behind many of those everyday conveniences lies a powerful but often invisible mechanism, the API.
The API, yeah.
And today we're doing a deep dive into exactly what an API is, how developers actually use it, and perhaps most crucially, how they make sure it works perfectly and securely through a whole suite of testing methods.
Right. So our mission for this deep dive is really to give you a shortcut to understanding these essential digital connectors.
Mm.
You'll grasp what they do, why they're so important, and the different ways their reliability is, well, guaranteed. You'll gain a thorough understanding of something that truly powers so much of our digital world.
Couldn't have said it better myself.
So let's start with the basics then.
Yeah.
API. That stands for Application Programming Interface. Sounds quite technical. Can you give us the simplest way to think about it?
Absolutely. At its core, an API is basically a set of rules and protocols that allow two different applications to talk with each other.
Okay, rules.
Yeah, think of it as like a standardized language or a very specific set of instructions that one piece of software uses to communicate effectively with another.
That immediately brings to mind this great analogy I heard. Imagine you're at a restaurant.
Okay.
You, the customer, you're like the first application. You want to order some food.
Right.
The menu, in this analogy, that's the API. It clearly defines what you can order, what services are available, and importantly, how to order them correctly.
Ah, I see where you're going with this.
And the kitchen, well, that's the second application. It prepares the food and responds to your order.
Makes sense.
Without that menu, that API, you in the kitchen just wouldn't know how to exchange information. You wouldn't know what to ask for, and the kitchen wouldn't know what to make.
That's a perfect way to visualize it. Yeah, that
Oh.
flow of information. First, one application sends a request to another's API.
Like me asking for a burger from the menu.
Exactly. Or in the digital world, that might be an app saying, I want weather information for New York. Or maybe add this specific product to my shopping cart.
And then the API just gets it, handles it.
Pretty much. The API receives that request, and then it processes it within its own application. It's like the kitchen taking your order slip and starting to actually prepare the burger.
Right.
And finally, the API sends a response back to the first application. This could be the weather API returning, temperature in New York is 25 degrees Celsius,
Hmm.
or the e-commerce API confirming, yep, product added successfully.
Okay.
That back and forth conversation, that's where the magic really happens.
So what does this all mean for us, the everyday user? You're saying we're actually using APIs constantly without even realizing it.
Absolutely, all the time.
Like when you log into a website using your Google or Facebook account.
That's an API handling the authentication, yeah.
Or when your weather app displays data, it's pulling that from somewhere else.
Usually, yes. Pulling it from an external source via an API. Even hotel and flight booking apps, the ones that gather data from loads of different airlines and hotels.
They're using APIs too.
They're doing it all through APIs. It really is the invisible glue holding so much together. I read that Netflix alone handles billions of API requests every single day just to make sure your movie starts instantly.
Wow. Billions. That's staggering. It's that pervasive.
It is.
Okay, here's where it gets really interesting for me then. The restaurant analogy gives us the big picture, the what. But now, let's peek behind the curtain a bit.
Let's do it.
How does that menu translate into the actual technical building blocks developers use, to make these digital conversations happen? Once you understand what an API is, how do developers actually use them?
Right. So, to use an API effectively, developers need to get their heads around a few fundamental concepts. First up are endpoints.
Endpoints, okay.
These are specific URL addresses. Think of them as unique addresses that represent access points to particular resources within the API.
So like specific phone numbers for different departments.
Kind of, yeah. Or specific page URLs on a website. So if you're dealing with user data, users might be the endpoint to get a list of all users.
Right.
While users would be for one specific user identified by their unique ID number.
Okay, so endpoints are like the specific sections on the menu, burgers, salads. Got it. What about the actions you can take with those sections?
That's where HTTP methods come in. These define the type of action you want to perform on that resource on that endpoint,
Methods.
like dot verbs.
Exactly like verbs. GET is probably the most common one. It's for fetching data, like loading your bank balance.
Precisely. When your banking app shows your balance, that's a GET request happening behind the scenes. Then you have PFOS. That's for sending new data.
Creating something new.
Yeah, maybe creating a new user account, or in our restaurant analogy, placing a brand new order.
Great.
PUT is for updating existing data completely. Like if you wanted to change your entire meal order, just replace the whole thing.
Right.
But if you just wanted to make a small tweak, like asking for no onions on that burger you already ordered, you'd probably use PAT-CH. That updates just part of the existing data.
Ah, subtle difference. PAT is replace, PAT-TH is modify.
You got it. And delete is, well, pretty much as you'd guess, for removing data, canceling an order maybe, or deleting a user account.
Okay, get, T, post, put, patch, delete. Those are the main actions.
Those are the big ones, yeah. And alongside those methods, you often send headers. These are like additional pieces of information sent with the request or the response.
Like metadata.
Sort of. Think of them like a little sticky note attached to your restaurant order that tells the kitchen something specific, like this is an urgent order, or crucially for security, I'm authorized to make this request. That often uses something called an authorization key or token.
Right, proving who you are.
Exactly. Now, if you're sending new data or updates using POST, PUT, or PAT-CH, that actual information, the stuff you're sending, goes into the request body. It's often formatted in a standard way, like JSON or XML, so the receiving end knows how to read it.
And when you get back, that's the response body.
That's the response body. That's the data the API sends back to you, the weather forecast, the confirmation message, whatever it is.
And what about when something goes wrong?
Yeah.
Or just confirming it went right?
Ah, yes. That's where status codes are absolutely crucial. These are standard numbers that tell you the result of your request.
Like the codes you sometimes see on websites.
Exactly like those. 200 OK means everything was successful. Your app just did what you asked. Smooth sailing.
Good news code.
Yep. Then you've got the infamous 404 not found. You've seen that one, the classic page not found error you get when a link is broken or you type a URL wrong.
Right.
And a 500 internal server error. Well, that's usually when the website or app completely crashes, and you often have no idea why. It means something went wrong on their end, on the server side. Not your fault.
Okay, so those codes are vital feedback.
Absolutely vital for developers to understand what happened with their request.
So, okay, we have endpoints, methods, headers, bodies, status codes. How does a developer actually put all these pieces together to use an API? Walk us through the general steps.
Well, the single most important first step, and I really can't stress this enough, is to read the API documentation.
The instruction manual?
Precisely. It's the instruction manual for the menu, the guide to everything. It specifies all the available endpoints, the HTTP methods you can use for each one, any required parameters, the expected format for requests and responses, and, crucially, how authentication works.
So skipping the docs is a bad idea.
A very bad idea. Imagine you're a developer building a simple app to show the current weather. Your very first step is finding a weather API's documentation and reading it carefully.
Okay, so you've read the manual. What's next? Are you ready to order?
Almost. Often, the next step is to get an API key, if the API requires one. Many APIs use keys for authentication, proving it's really your app making the request, but also for things like tracking usage and controlling access levels.
A VIP pass or a library card?
Good analogy, yeah. It identifies you. Then, once you have your key and understand the rules from the documentation, you send requests.
How do they actually do that?
Developers use various tools. There are specialized applications like Postman or Insomnia, which are great for testing things out. Or you can use simple command line tools like curl. Or, most commonly when building an application, they use built-in features or libraries within their programming language, like Python's requests library, or JavaScript's fetch API, or Java's HTTP client.
So you use one of these tools or libraries to send, say, a JACT request to the Weather API's endpoint for London.
Exactly. You'd specify the endpoint URL, the GET method, maybe include your API key in the headers, and then once the API sends back a response,
They process it.
you process the response. That's when your app takes the data it received. Maybe it's that JSON data saying 20 degrees, partly cloudy, analyzes it, and then displays it nicely to the user in the app's interface.
Okay, that paints a much clearer picture of the how.
Good, because if we connect this to the bigger picture now, once you understand how APIs work and how developers interact with them, This raises a really important question. How do you know they're actually going to work reliably?
Right. And securely.
And securely, absolutely. And how do you know they can handle all the requests being thrown at them? It's not just about making sure the basic code works in a perfect scenario. It needs to work under all sorts of conditions.
And that's where API testing comes in.
That is precisely where API testing comes in. It's a whole discipline dedicated to this.
It's truly mind-boggling when you think about the level of rigor required for something we just, take for granted every single day.
It really is.
And this isn't just one type of testing, is it? I understand there are several distinct kinds, each serving a unique and absolutely crucial purpose.
That's right. It's not a one-size-fits-all thing. There's a whole ecosystem of testing designed to guarantee reliability and performance from different angles.
Okay, let's dive into these then, because they sound essential to getting that seamless experience we all expect. Where do we start?
Let's start with the foundation, functional testing.
Functional. Okay, it sounds like checking if it functions.
Pretty much. It's all about verifying that the API performs its expected functions correctly. Does it return the correct data when asked? Does it handle error situations gracefully? If you ask it to update data, does it actually update it correctly?
So just the basic, does it do what it says on the tin kind of check.
Exactly. How do developers do it? Well, you provide specific input data based on what the API's functional specifications say it should handle. You send that data through the API to the application, and then you compare the actual result the API gives you back with the result you expected to get.
Makes sense. When would you do this?
This happens early in development, definitely. And whenever new functions or endpoints are added, it's about ensuring each individual piece works as intended before you start connecting things together.
Okay, so functional testing checks the individual parts. What's next?
Well, once your API is functionally sound on its own, the next big question is, can it play nice with others?
The integration part.
Precisely. That's where integration testing comes in. This checks the interaction and communication between different system components, or maybe even between multiple different systems that are all using the API. Does the API integrate correctly with, say, the database, or with an external payment service, or other internal modules?
So it's about seeing if the different parts of the digital kitchen are all working together properly, not just in isolation.
Exactly that. The process usually involves creating a test plan that defines specific scenarios where the API needs to interact with other components. You send input data that mimics that real data flow between components, and then you compare the results to make sure the interactions are smooth and the data flows correctly between them.
When is this most critical?
It's crucial right after you've done the individual functional testing, especially when your API needs to talk to databases, external third-party services, or other internal APIs or modules. It's absolutely vital for ensuring that changes you make in one API don't accidentally break how it interacts with other connected systems.
That leads perfectly into my next thought. What happens if you fix one bug, maybe based on functional testing, but you accidentally break something else that used to work? That sounds like a developer's nightmare.
Oh, it absolutely is, and that's the specific nightmare that regression testing is designed to prevent.
Regression testing.
Okay. Its whole purpose is to ensure that any new code changes, whether it's a bug fix, a new feature, a performance tweak, whatever, haven't accidentally broken existing functions that were previously working just fine.
How does that work in practice? Do you just rerun all the old tests?
Essentially, yes. You take the functional specifications and the input data from your previous test runs the ones that passed before. You run those exact same tests on the new version of the application or API, and then you compare the results to the results from the old version. If the results are consistent, great, no regression occurred. If something fails, that used to pass.
You found a regression bug. You broke something.
Exactly. You've introduced a new problem. I remember one time, a seemingly simple API change, if it hadn't been caught by regression testing, it would have stopped our main Add to Cart button from working entirely. Imagine launching that.
Yikes. That's a critical safety net then. So this is done pretty often.
Oh, yes. Ideally after every significant code change, big or small. And absolutely critically, before every new release goes out to users. It prevents introducing new problems while you're busy fixing old ones or adding cool new features.
Okay, so functional, integration, regression. Those seem focused on correctness. What about performance? Making sure it can handle the traffic.
Excellent point. Now we get into performance testing. First up is load testing.
Load testing.
This evaluates the API's performance under normal, expected load conditions. The key here is normal or expected. The goal is to see if it can comfortably handle a specific number of users or requests concurrently without significant slowdowns or throwing errors.
So it's not about trying to break it, but seeing if it can handle like a typical busy Thursday afternoon's worth of traffic without falling over.
That's a perfect way to put it. Developers use tools. Apache JMeter is a very popular one, but there are others to simulate many concurrent users or requests. They send these simulated requests to the API, and then they carefully assess things like response time, how quickly does the API answer, throughput, how many requests can it handle per second, and resource usage, like CPU and memory, under that anticipated load.
And when do you run these?
Typically before a major launch or a significant update, you want to ensure that the API can meet its performance requirements in the real production environment. It helps identify potential bottlenecks before they impact actual users.
Okay, so load testing is for expected load. Is there a test for unexpected or extreme load?
Yes, there is, and it's distinct from load testing. That would be stress testing.
Stress testing. Sounds intense.
It is. Stress testing pushes the API beyond its normal operating capacity. We're talking high, sometimes even unrealistic loads. The goal here is to find its breaking point, or at least to observe its behavior under extreme conditions.
Like what kind of conditions?
Things like an overwhelming number of requests all at once, or maybe simulating resource exhaustion, like running out of memory or database connections. The goal isn't just to see if it breaks, but how it breaks, how durable it is, and importantly, how well it recovers after the stress is removed.
So this is about intentionally pushing it way past the limit to see where it truly cracks.
Exactly. The methodology is similar to load testing. You use tools like JMeters again, but you deliberately and gradually increase the load to levels far beyond what's expected in normal operation. You assess its durability, you carefully observe any errors or crashes, and you watch how the system recovers afterwards.
Why would you want to know that, apart from morbid curiosity?
Fair question. It's used to determine the absolute maximum limits of the API. It helps understand its behavior if a critical component fails, or maybe under a denial of service attack scenario. And it's really important for planning things like disaster recovery procedures and figuring out scalability strategies, knowing when you'll need to add more resources.
Okay, that makes a lot of sense. Load for normal, stress for extreme. What else is crucial? Security must be huge.
Huge is an understatement. Next up, and you can argue it's one of the most critical, especially given today's digital landscape, is security testing.
Right.
The core question here is always, fundamentally, is there anything easily hackable? Security testing focuses intensely on identifying and fixing API vulnerabilities that malicious actors could potentially exploit.
It's like security flaws or issues with who's allowed to do what.
Exactly. Authentication problems, proving who you are,
Yeah.
authorization problems, checking what you're allowed to do, data exposure issues, all that stuff.
That sounds incredibly important, especially with all the data breaches constantly in the news.
It truly is. A single vulnerability in just one API could potentially expose millions of users' sensitive data. So API security testing isn't just, a nice-to-have best practice anymore. It's an absolute existential necessity for many companies.
So how do they test for these hidden dangers?
It works by using specific security test specifications and techniques. Testers might try things like SQL injection attacks. They might simulate distributed denial of service, DDoS attacks. They look for ways the API might accidentally leak sensitive data. They probe for weak authentication mechanisms. Essentially, you send specially crafted, often malicious-looking requests to the API to actively attempt to breach or bypass its security controls.
Trying to think like a hacker.
Precisely. You identify those vulnerabilities, and then critically, you fix them. And this isn't a one-off thing. It needs to be done continuously throughout the API's development lifecycle, especially when making any significant changes to authentication or authorization logic. And it's absolutely non-negotiable before any launch or major update to protect that sensitive user data.
Okay, one last type you mentioned was UI testing, but specifically in the context of an API. That confused me a little. Isn't UI testing normally about, clicking buttons on the screen and seeing if they look right?
It is often perceived that way, yes. And traditional UI testing does focus on the graphical user interface itself. But when we talk about UI testing in the API context, it's a bit different. It's really about checking the accuracy and correctness of the interaction between the API and the user interface that the user sees.
So it's testing the connection between the front end and the back end via the API.
You've got it. Does the data the API provides actually display correctly in the UI fields? Do user actions in the UI, like filling out a form and hitting submit, correctly translate into the right API requests being sent behind the scenes? And are those requests processed correctly by the API with the results then reflected properly back in the UI?
So you might interact with the UI, say, clicking that Buy Now button, but the test is actually verifying that the correct POST request with the right item ID and quantity was triggered, and maybe that the success message from the API response then correctly updated the UI to say, item added to cart.
That's exactly the kind of scenario. You interact with the UI element, a button, a form, whatever. Then you verify, perhaps by monitoring network traffic or using specific testing tools, that the correct API request was triggered. And then you confirm that the data eventually received from the API is accurately processed and displayed back in the UI.
When would you focus on this type of testing?
It's particularly important when you're developing a new UI that relies heavily on an existing API. Or maybe when you make changes to an API, you need to ensure those changes don't negatively impact how the front end displays information or functions. Ultimately, it's about ensuring that seamless and consistent end-to-end user experience.
Wow. Okay. We've journeyed from just the basic concept of two apps chatting all the way through to these really intricate ways we ensure those conversations are robust, secure, and performant.
It's quite a stack of considerations, isn't it?
It really is.
Yeah.
You've now got, I think, a powerful understanding of the digital backbone, the hidden plumbing behind so many services you use every single day. It's amazing to think how many different angles developers have to cover just to make sure these connections work reliably.
And knowledge is most valuable when it's understood and applied, right? APIs truly are the unsung heroes of the modern internet, I always say.
Hmm.
They manage and simplify incredible complexity, allowing these vast, sprawling networks of services to somehow work together, often seamlessly. Understanding the sheer depth of testing that goes into them, from basic functional checks right through to heavy stress testing
Yeah.
and rigorous security assessments, it really shows just how vital and, frankly, how delicate these digital connections can be.
It really makes you think. And it raises an important question, perhaps, for you listening to consider. Knowing how critical these APIs are and how much testing they undergo, what might be the next big challenge or innovation in how applications talk to each other? Or how we ensure their continued reliability in an even more connected future?
That's a great point. And maybe think about how this concept of APIs, of standardized interfaces allowing complex systems to communicate, might extend beyond just software. If we see similar principles applied more widely in other complex systems that need to talk to each other, perhaps in managing smart cities, or coordinating autonomous vehicles, or maybe even understanding communication pathways in biological systems, there's always more to learn and connect.